So we're in chapter 5 today, basic properties and reducing to lowest terms, which is the name of section 5.1. And yes, we're going to have more than one video here as we get into lots of different stuff in this section. First thing we want to just remind you of is what a rational number is. Basically, a rational number is just a number that can be expressed as a fraction. Okay, so we just have a numerator and a denominator, and it is basically the ratio or the fraction. But one of the things that is necessary to bring up on several occasions in these videos is that the bottom number cannot be 0. So sometimes we have to tell our reader that that number can't be 0. Sometimes we don't have to. Like in this case, we don't have to tell anybody that the 4 cannot be 0 because it's not. But in a rational expression, which is labeled as, let me just put rational expression, that is basically an algebraic expression or a polynomial over a polynomial. And the way they write a polynomial over a polynomial are with the capital letters P and Q. Now, in this case, we have to say Q cannot be equal to 0. Just a reminder, because sometimes, because I said it's a polynomial over a polynomial, we could have an expression like this. Well, that is all well and good, and we can find out what x equals, but we do know that x cannot make that 0, so x cannot be equal to a -5, because if it was -5 plus 5 is 0, and that can't be the case. So oftentimes we don't even have to say that, but then there are a few times later on in the class where we'll be able to, or we'll have to say, when x is not equal to -5 or does not make the denominator 0. And one of the things that I need to bring up, let me pull this out of the way here, is when we have a number like 6 over an 8, we can multiply the top number and the bottom number by the same number, and we get an identical fraction. It does not change the value of the fraction at all by multiplying the top and bottom number by the same number. It's also true when we divide the top number and bottom number by the same number. So what I'm saying here is that when we divide them both by 2, we get the same as if they were left alone, or if we multiplied by 2. We have not changed the value of the fraction. We've just changed how it appears. So 3/4 is the same as 6/8, which is the same as 12/16. So this is a really good tip to have in your belt, because we're going to be multiplying top and bottom numbers by the same number, and we will be dividing by the same number, and just recognizing that we can do that without changing the value of those numbers at all. All right, so to get started, we'll just get started in example 1, and we're just reducing to lowest terms. We're looking at this fraction, and we're reducing to lowest terms. Now, one of the things, remember, x cannot be 3. But don't always need to say that. You just assume that the reader knows that. Now, like I say, in other cases, we can't assume that. We have to let everybody know. So one of the things I teach when I'm doing this is when we've got fractions, especially when we have polynomials in both numerator and denominator, we simplify the numerator, we simplify the denominator before we cross this line and try to combine these things. So we do everything we can on top, everything we can on the bottom before we cross the line. So x squared minus 9 is the difference of 2 squares. And we can't do anything to the bottom. All right, so notice between this binomial and this binomial is a multiplication sign. So when that's the case, we can get rid of our x minus 3 over x minus 3's. And the reason we can do that is because this over this means it's the same thing on top, same thing on bottom, and that always equals 1. So when that is true, we can cross those out, and we get for our final answer, or our simplified version of x squared minus 9 over x minus 3, we get x plus 3. So let's look at example 2. All right, so we're going to look at just the top first, and we can factor it. Two numbers multiplied together give me a negative 6. Added together give me a negative 5. Okay, and then y squared minus 1 is a difference of 2 squares. And if you look at this, I've got a y plus 1 there and a y plus 1 there, leaving me with that for the answer. Okay, let's keep cruising along here and look at example number 3. 2a cubed minus 16 over 4a squared, minus 12a plus 8. 2a cubed minus 16, we can factor out the 2. And on the bottom, we can factor out the 4. Okay, so nothing really weird there. Remember from the last chapter, let me move this over here a little bit, that we can rewrite this as a cubed minus 2 cubed. And let's go ahead and factor the bottom. A minus 2 times a minus 1. Okay, factor that into two binomials. Now, if you recognize this here from the last chapter, this is a difference of 2 cubes. Difference of 2 cubes, we can write that as, let's do it down here. First term is our first number minus our second number, so a and 2. And then we've got our first number squared plus 2, our first number times our second number, plus our second number squared. Okay. And that is again over 4 times a minus 2 times a minus 1. All right, so let's look at what we can get rid of. This over this is 1. We can reduce 2/4 to 1/2. And then this here we can't do anything with. So we have just a squared plus 2a plus 4 on top. I guess you could put the 1 there if you wanted, but no reason to do that. And on the bottom, we have the 2, and then we have the a minus 1 left. And that's our final answer for that one. Okay, let's jump up to example 4. Okay, so one of the things that I tell students, and I don't remember if I told this group, is whenever you have a list of a list of terms and you have 4 or more even numbers, 4, 6, 8, 10, you can probably group. So that's what we're going to do, is we're going to look at grouping both the numerator and the denominator. So let's put parentheses around this and around that, and here, and here. And we get on top, in this one here, we can factor out an x, and we've got x minus 3 left. And this one, we can factor out an a, and we have x minus 3 left. Okay, now let's look at the bottom. We can factor out an x, and we have x minus a, and we can factor out a 3, and we have an x minus a there. All right, so that being the case, let's go ahead and bring our a and our x together, and our x minus 3 together, and that's going to be over x minus 3. And then we've got x minus a. Okay. That being the case, let's see what we can cross out here. X minus 3 and x minus 3. So we're left with x plus a and x minus a. Now notice, we cannot cross out the x's. We cannot cross out the a's. This plus sign and this minus sign lock these terms together. So you can't cross one out. You have to cross like up here. You cross the whole thing out. Well, this and this are not the same. This is a positive a. This is a negative a. Can't change it. Can't do anything about it. And that ends up being what we've got for an answer. Now, let me move into, I'm going to leave that one right there. Let's go into example 5 because it does look a little bit different. Let's look at a minus b over b minus a. Okay, so this one here, our a's were different signs. Our x's are the same sign. That's why I'm saying we can't cancel, we can't do anything in order to make this simpler. This one has a positive a and a negative a. This has a negative b and a positive b. So notice that both the letters, a's and b's, are both opposites. Well, when that's the case, you can kind of finagle this around in order to cancel. Up here you can't because this is not, these two x's are not opposite. So what we can do here, we are going to factor out a negative here, and that gives me, when I factor out a negative, negative a plus b. Whenever you factor a negative out of a polynomial, it changes the sign of everything in the polynomial. So I pulled this negative out, and it made my a negative and my b positive. Because if I put it back in, a negative times a negative gives me a positive. A negative times a positive here gives me my negative back. So I can look at it and be like, oh, okay, it didn't change it. Okay. Are those the same? Well, yes, they are. This has a negative a and a negative a, a positive b, a positive b. But let's flip this around just so you can see. Negative a plus b over, let's flip these around, negative a plus b. Okay, see, they are the same. So that can cancel and that can cancel. But that doesn't give us negative 0. It gives us negative 1. Whenever everything cancels, we always have a 1 there still. So our answer is negative 1. Let's look at example number 6. X squared minus 25. Obviously, difference of two squares. So we get x plus 5, x minus 5, over 5 minus x. So notice, my x is negative here, it's positive here. My 5 is positive here, it's negative here. So I can switch these two around and then be able to cancel with this one here. Can't do anything with that one. So I'm going to factor out a negative on the bottom. Okay. And then this can be written as x plus 5. Nothing happened there. Nothing happened here. But don't forget the negative out there. I'm going to flip these two around because that's a positive x and a negative 5. And then I can cancel that and that. So I'm left with x plus 5 over negative 1. Or I can just put the negative up here and get rid of that. So negative the quantity x plus 5, not just negative x plus 5. Okay, so hopefully this first section, 14 or 5.1a, wasn't too bad. We're going to get into two more pieces in this section, and they're going to get a little bit tricky. So we'll see if I can make it as simple as possible for you, but you're going to really need to focus and follow on. So get ready for 5.1b as in boy.